So let us start. A very good morning to all of you. Today we are blessed with got a very good speaker on the latest technology, that is AI and machine learning and Industry 4.0. So before we start with the session, I'd like to very quickly introduce our today's speaker to the audience, and let me introduce our student to our speaker also. So today's speaker is Dr. Ajit Abraham sir, who is presently director in Machine Intelligence Research Lab, that is MIR Lab, USA. Dr. Abraham's research and development experience includes more than 27 years in industry and academia. He received the MS degree from Nanyang Technological University, that is NTU, Singapore, and PhD degree in computer science from Monash University, Melbourne, Australia. He works in a multidisciplinary environment involving machine learning intelligence, cyber security, sensor networks, web intelligence, scheduling, data mining, and applied to various real world problems. He has given more than 100 conference, plenary, lecture or tutorials and invited seminar or lectures in over 100 universities around the globe. Dr. Abraham has more than 23 university associations globally for teaching and research. He has 38,237 citations and 93 H-index. As an investigator and co-investigator, he has won research grants worth over $100 million from different countries like Australia, USA, EU, Italy, Czech Republic, France, Malaysia, and China. In these areas, he has authored or co-authored more than 1,100 research publications, out of which there are 100 plus books. So today's topic is AI and machine learning based Industry 4.0 and beyond. Dear student, as you know, we are in the era of Industry 4.0, which is driven by cyber physical system. To set the tune of this particular webinar, let me just give an example to understand how that Industry 4.0, how the technology of Industry 4.0 is available with our daily life. For example, if you consider any smartphone, okay, so nowadays smartphone, and you know that sensor is the device which is main driven force for implementing AI for Industry 4.0. And even you know that if you consider our daily life incidents like managing our sleep time also, it can be managed by, the technology of Industry 4.0. Our smartphone contain a sensor which can motion our, which can sense our motions, and intelligently it can decide our sleep time, optimal sleep time. You know that the optimal sleep time is a multiple of sleep cycle, and the duration of sleep cycle is 1.5 hours. So based on your movement, once you get, once you get asleep, it start calculating, it sense that at what time you are getting asleep. And from that time, it can calculate your optimal sleeping time, which will be the multiple of that sleep cycle, which consists of, two things, NERM and ERM. So that's one example how the device, sensor, and the technology which are involved in our daily life also. And that is the driving force for today's Industry 4.0 evolution. So we are, let me introduce the student to our speaker also, sir. Under Amity University, Jharkhand, Ranchi, we offer various programs under engineering and technology domain, where the student from various streams of BTech program, BCA program, BSc IT program, and MCA program has joined today's session. Not only the student, our respected faculty members has also joined this today's session. And let me also welcome, along with our speaker, let me also welcome the other panelist, our Honorable VC Sir, Professor Dr. Raman Kumar Jha Sir is with us. Our respected Director Sir, Professor Dr. Ajit Kumar Pandey Sir is with us. And our respected Professor, Dr. Mithun Chakraborty Sir, who is the main organizer of this year, is with us. So before we hand over the session to our respected speaker, whom I have already introduced to the speaker, to the students or attendees, let me invite our honorable VC sir to say very few words to bless our attendees. Over to honorable VC sir. VC sir, please unmute your mic. Yeah, sir, over to VC sir. Sir, if you if you can say very few words to enlighten our students.
Just a very good morning to all the panelists, including a special welcome to Dr. Ajit Abraham for sparing his time so valuable for addressing us, and that too on a very, very important topic, which is taking the technology altogether in a different way in all aspects. Very briefly already conveyed by Dr. Samantha. I congratulate the organizers, Dr. Mithun Chakraborty and the whole team who have worked behind to make this day before all of us. I urge the students to spend their time and take notings and ask questions as to how you can be part and parcel of artificial intelligence, without which, especially if you are in a technological field, you cannot survive. So here is an opportunity. Thanks to everyone who has made it possible. We must take the best advantage of the expertise available, and maybe go ahead to think of collaborating with him to write papers and seek all the possible advices. My sincere thanks to everyone who has joined as a student or a faculty members, and best wishes. Over to you, Dr. Samantha. Thank you.
Thank you. Thank you very much, sir, for your words of blessings. Now I would like to request, based on my request, our director, sir, has taken time to join the session because sir is going to attend a very important meeting on exam aspect. So I would like to request our respected director, sir, to say a few words of blessings for our students. Over to director, sir.
Thank you, Dr. Samantha. Very good morning, our Honorable Vice Chancellor, sir, Honorable Distinguished Speaker for the day, Dr. Ajit, with whom I am sharing the name, Dr. Mithun Chakraborty, and all the student and the faculty participants of this webinar. In just one line, I would say, our intelligence is based on how good we are in artificial intelligence today when we are in Industry 4.0 era. Everything has been done using artificial intelligence. The other day I was listening that the entire defense is going to shift on artificial intelligence, where the drones will take care of the things happening around the border, and on the social media platform, whatever being searched, whatever being posted, everything will be taken care of by artificial intelligence. Even the customer's preference and behavior is going to be taken care of by artificial intelligence. So Industry 4.0 has brought artificial intelligence into the picture, and this is going to help mankind in many ways. So once it was said that one step of man and a leap for the mankind when man jumped on moon. So this artificial intelligence is not going to be lesser than that one step of the man on the moon, when entire things are going to happen taken care of by artificial intelligence. What you think, what you do, how you behave, how many steps you have taken in the day, how many steps you should take, what diet you should take, what diet you have taken, how much you have taken more, or less, everything is going to be taken care of by artificial intelligence. Even though it is artificial intelligence, it is poured with the human intelligence. So it is the human intelligence which has created artificial intelligence, and it is artificial intelligence which has created a new paradigm, a new dimension to the entire industry. So today's topic is really very interesting topic, and I believe it is going to be highly important and crucial topic for all the students who are attending this session. They should uh, take each and every word with utmost care and try to understand each and everything. And not only during the webinar, even after the webinar, two of the eminent faculties are here, Dr. Mithun Chakravarti, Professor Dr. Mithun Chakravarti, and our program coordinator, Dr. Biswarup Samanta. I believe both of them, they will be guiding our students even after the webinar on this very crucial topic, whether it is artificial intelligence or machine learning or the use of the tool in Industry 4.0, etc. It is going to be a boon for all the students who are attending this session. I wish, on my personal behalf and on behalf of the entire Amity University Jharkhand, all the best of learning to all the students attending here, and the best wishes for all the faculty members who are attending this webinar session. Uh, Without taking much time, I am handing over the podium to Dr. Viswarup Samanta to take the webinar session forward. Thank you. Over to Dr. Viswarup Samanta.
Thank you very much, sir, for your kind words of blessing. So, dear attendees, dear students, so as you know that today's topic is AI and ML based Industry 4.0 and beyond. So now I'm going to hand over the podium to our respected speaker, and I'd like to request our respected speaker to keep last 10 minutes of our session. We need to close our session at sharp 11 o'clock. So I'd like to request you if you can conclude your speech by 10:50 to 55. So then last 5 to 10 minutes we can keep for question and answer session. And I would also like to request our attendees, please keep your questions through the QA box to all the panelists. So with this, now I would like to welcome respected Dr. Ajit Abraham sir to deliver his session. Over to Abraham sir.
Very good morning to all of you. I think it is indeed a great pleasure to be with all of you this morning. I am grateful to the organizers for inviting me to this conference related to wireless communication and information security. And today my topic might sound a little bit different from the theme of the conference, which is more focused on wireless and security. But I guess my talk will be more generic, and it can be easily taken to any domain. Just like the director told before, AI is now everywhere. It's more like a fabric. So basically, from security to networking to healthcare, even to law enforcement, basically you can see AI in all aspects of our daily life. So I hope that we will be able to learn from each other and try to evolve our current technologies, find more applications, etc., etc. And it is also important that we can also make use of this challenging times, because COVID-19 has changed the way we live, the way we interact, even the way we do research, because we are not able to perform our experiments in labs. Instead, we have to be at home. We are not able to travel to attend conferences. We have to be at office or home to do these things. So basically, a lot of changes because of this pandemic and the way it is going. But on the other side, if you see the positive aspects, we can also make use of this time to transform the way we do certain things to make it more productive. For example, I am the editor-in-chief of a journal, and when I compare to last year and this year, there's an increase of about 50% of the production of papers, which means that people are more engaged in research because of COVID-19. It's not only on COVID-19 itself, but people are finding more time to sit in front of the computer or sit in the office or sit at home focused on research and try to enhance your productivity. So I think if you look at it from a positive side, there are good aspects for being at home or office, whatever we are. So I hope that together we can survive this current situation in a much better way. So thanks again to the organizers for putting this conference, and unfortunately we had to do this online. Actually, I'd never been to Ranchi, and actually I'm a big fan of MS Dhoni, so I always link Ranchi with Dhoni. And actually I was not aware of this campus until Dr. Mithun Chakravarti invited me. Actually, I am very much involved with Amity Noida since I would say 2014. I'm actually an adjunct professor of Amity Noida as well as Amity Jaipur. And I usually go there like once in a year until last year. This year I couldn't go. So I'm actually very familiar with the Amity family. So again, I'm very happy to be back with the same family. So let me go back to the main topic. So today I'm going to talk about Industry 4. For those who are very new to this, I would like to give a quick introduction. What is Industry 4? And the role of AI and data sciences. What AI and data sciences could do in this environment. So Industry 4 is, in a nutshell, it is the fourth industrial revolution. So it is more like the digital transformation of the way manufacturing is happening or happened in the past. From mass production, we are slowly moving to mass customization. For example, you can imagine if you want a pair of shoes, you go to a shoe store and, for example, you want a Nike shoes, and you look at for the Swiss sign, where it is and color, the shape, but somehow you didn't like the way the logo is placed. So you need some customization. So in the current market, it's not possible. You cannot really customize a Nike shoe. So imagine if you have a online portal which is linked to customers, and then it goes all the way to manufacturing and to delivery. So it is more like a seamless network of events where there are not much humans involved, and most of the things will be done in an automated way. So basically, we will be using a lot of technologies. Today, I'm going to talk only about the role of AI and data science. But if you look at if you go a little bit down, you would see a lot of technologies, virtual reality. Even you need high performance computing. You need various other technology. For example, even networking. You need nice networking technology. Even you need security inside. So there are various aspects you can think about from your own perspectives. So I will quickly go through what is Industry 4, then we will straight away jump into data sciences, intelligent computing or artificial intelligence, and I will present some of our own work in this field, followed by some conclusions. So that is a plan of my lecture. So actually, if you look at the Industrial Revolution, we started in the beginning or the end of the 18th century, where we used steam and mechanical power for basic movement. For example, for moving a wheel, for transferring water, or some wheel for moving something. So basic automation for small stuffs. Then in the beginning of the 20th century, we invented electric power. We were able to use this power in a massive way. We were able to connect different cities. We were able to build small cities and interconnect them. We were able to connect communities together. Manufacturing flourished, automation flourished in a small scale. And that was the second industrial revolution. And in the beginning of the 70s, we had the third industrial revolution, when we had sort of like powerful computers. Then we had some developments in electronics, embedded systems, embedded devices, small scale automated machines. So these all led to the third industrial revolution. So where AI didn't play a big role because we didn't have much powerful computers to process it. But when I look at the methodologies and the things available. Even in the 70s, we had actually basically all the basic AI tools, but we couldn't use it very much because we didn't have powerful computers. But today we have the best of the best. We have powerful processing machines. Even we don't have a powerful computer. We have cloud, we have edge, we have all these wonderful computing platforms. We have artificial intelligence. We have Internet of Things. We have cyber-physical systems. We have virtual reality. We have various other technological interfaces. So imagine all these things growing and working together seamlessly without much human intervention. So this is actually the uniform of Industry 4.0. So Industry 4.0 uses all these technologies to do several things. It's not only for manufacturing, even though the emphasis is on manufacturing, but ultimately it should also go back to the community. So the end fruit should also go to the community. So it can be also used for several aspects. For example, healthcare. So for example, e-commerce, or even banking, even finance, even law enforcement. So you can think about various dimensions of Industry 4.0, how we can utilize it for uplifting our community in a big scale. So IoT is about a network of sensors, devices, even machines, which could be used for monitoring things, or like instruments, or certain devices, and basically the way we use them, we can see a lot of impact. It could actually reduce the costs. For example, if you have a business and if you're using traditional methods, and if you use IoT, probably it can reduce the cost. It can actually improve efficiency. You can actually make things better. You can actually offer innovative services to your customers. Even it can create new revenue streams, because when you have more ideas, you can create new revenue streams. And imagine, even education, because since most of us work in education, so even education, we can think about certain ways how we can use these methods to improve the productivity and efficiency. So today I'll be talking, I won't be talking a lot about applications, but I'll be talking a bit more about technologies, because applications you can find everywhere. So when you talk about all this Industry 4, AI, data sciences, one of the common problems which we come across is big data. So we need to handle exabytes, petabytes of data for large-scale applications. So we need to deal with data which is very big volume. We need to deal with data which is of high velocity. We need to deal with data which is which has a lot of variety. For example, you can imagine if it is from a server, you would see HTML, you would see multimedia, you would see streams, you would see a lot of things. And imagine you might even have to deal with networks, for example, like social media, etc., where you need to translate the communication, etc., into network, and then you need to understand what is going on within this network. Capacity, there could be several networks, and sometimes we are not certain whether the data coming from this network or this sensor really belongs to this particular project or this particular network. So we need to deal with uncertainty, imprecision, vagueness, and these are just 4 V's. I think there are also several V's, but let us move to the the main focus. You can easily find this from the literature. So in terms of technologies to handle big data, it has been there since almost 15 years. It's really a very matured field. We have like Hadoop and MapReduce to handle a lot of data. It is more like the kitchen to handle big data. And then if you want to handle a little bit more into analytics, there are several off-the-shelf tools. Some are commercial, some are free libraries. For example, like there are nice packages in R. There is MATLAB. There is SPSS SAS, which has very nice data analytics tools. Then if you want to come a bit more deeper. You want to drill a bit more deeper. You want to mine more information, more insights. For example, you are running an election campaign. You have 10 million tweets, and you want to find, what is going on, like under this 10 million tweets. You want to summarize. So basically, if you can, understand the structure of these tweets, and you can actually summarize, or in a way you can find the sentiments behind these 10 million tweets using modern AI technologies, or using big data technologies. So we need to customize some of our well-known AI methods. We might have to use some natural language processing, etc., to assist, and then we can easily find the underlying sentiments from these 10 million tweets. So it is all about how we want to do this, and how much processing we can afford at different stages. For example, sometimes you need decisions on the fly. Sometimes you need very good decisions and you can wait for some time. So you can have a lot of different models, and you can find the best decision you could get from different models, and then you can find the best. So there are various ways to look at it. So in AI, we call it as it's all about finding patterns. So in a summary, if you have data, and if you want to find information, it's more about finding patterns. So what is a pattern? So pattern could be, for example, iris, could be fingerprint, could be face, could be palm, could be signature, could be voice, could be the way we move our hands, could be the way we walk. So these are all patterns. So the idea is whether we can use any methodologies to understand these patterns. So if you can find patterns from data, then that is sort of finding knowledge from the data. So we can say that in business, if you can find something which our competitor doesn't know, means we can actually perform better than the competitor. So it's more like business intelligence. So finding patterns, it is another way to look at is finding knowledge from a database, or customer transactions, or student feedback, or tweets. Okay. And there are different types of data. For example, the one you see on the screen is the license plates from different states, the US. If you look at these license plates, even though it looks very colorful and probably it might look a bit complicated, but if you look a bit deeper, you could see that each number plate has some uniqueness. You would see some number, the state name, and you can think about some very good segmentation methods and use some symbol classifiers to understand which number plate is from which state, etc. It is very easy. Structured data, well defined. You can easily use any traditional methods. So usually for any machine learning model, what you do is we try to first we decide, okay, what type of model we should use, whether we should use a neural network, whether we use an expert system, whether we should use some machine learning model. So basically we try to train the model using some data. We pre-process the data. We try to make sure that there is no noise. There are no correlating features. Okay. Missing information, data which is not which is not authentic, or probably we cannot be sure about that particular feature or that particular input. So once you do this, then we do some feature extraction, feature selection, etc., and then we try to build a model, and then we save it, and then we use the test data which is not used before, and then we pass the test data, and then we see the training and test results, how they are, and if the results are very similar, then we can say that okay, the model works pretty well for this particular application. So AI is very good for this particular application. But if the test data is testing error is very, very high compared to training data, which means that the generalization is very poor. So probably you might have to use some other model instead of that model, or probably you need to change the fragmentation of data. Probably you need to take a new set of training data, a new set of test data, and see how good it is. And probably you need to do some iterations how it performs. So you can use some traditional data analytics methods like fragmentation of data and then like tenfold validation, etc. And then you can make sure that it works in all conditions. Okay, so there are many ways for picking up the right features. It's also important, like I mentioned earlier, it's also important to have the right features. So if you have the wrong features, it can also bring down the performance of the algorithm. So it's important to pick. First, I mentioned about the data should be authentic, reliable, good quality, and then we need to make sure that we have the best features. We need to deal with missing features. You need to deal with noisy information. Sometimes you need to deal with curse of dimensionality. You might have thousands of features, because when you have thousands of features, we need to build a big model, and then this could lead to a lot of processing, and this could also lead to delays in finding the answers. So basically, you need to compact the number of features so that you can also build a more compact model. So when you have different models, for example, here you are seeing the classification of two sets of data. For example, you have two types of fish. One is salmon and one is sea bass. If you look at the bottom of the screen, on the left side, you would see a very simple model, y is equals mx plus c, straight line. So if you just straight line, whether you can separate them, probably that is the best model. On the other hand, if you use machine learning, if you use complicated AI models, you can actually have a addition boundary in the shape of a snake. For example, the one you see on the right side, you would see that basically you can actually categorize each and every point using the addition boundary. But in theory, it is always better to have a more simpler model than a complex model. So if you can solve a problem using a simple model, we should always go for it rather than using a complex model. Because a complex model, once it fails, it's very difficult for us to understand why it failed. Or we cannot even explain why you're getting good results. So a simple model, probably it is much easier to explain, and you can actually have better control on its performance. So it's always better to have a very, very simple model for problem solving. So if you look at AI, we can actually categorize the problems into several domains. So one domain is the field of functional approximation. So we have regression. For example, if you look at the Indian stock market, so what is the stock value today, tomorrow's value? Classification, whether you can categorize. For example, you have X-ray images of a patient with COVID-19, and you have an X-ray image of a patient who is COVID negative. Whether we can identify them using AI methods, classification, symbol classification, patterns, pattern recognition, like I mentioned earlier, like iris or gait, hand moving patterns, signatures, voice, whether we can recognize. So that category, that field, or that sort of problems, we could usually call it as functional approximation. And clustering is also part of, I would say, part of functional approximation, where we try to group similar looking objects as close as possible and objects that are different as far as possible. So basically the idea is to keep similar looking objects together and objects that are different to keep them as far as possible. It's a very interesting topic. Several methodologies, several results, and it is often used for, I would say, high-level data analytics. Because in many real-world environments, we don't know much information about data itself. So people tend to do clustering to get some high-level information first, and then we try to use some fine-tuned methods to drill deeper to find more information from these clusters. Okay? So that is one way to do analytics when you have a lot of data. Approximate reasoning is another important field where we try to deal with vagueness, imprecision, uncertainty, etc. For example, if you look at the screen, you would see there are two good examples. Sometimes it's good to be precise, but many times precision doesn't work in real life because we cannot afford the computation or the time. So many times what we need is how to deal with these approximate information and make realistic, practical, optimal or near optimal solutions. So from approximate information, idea is to use that information, translate to optimal or near optimal solutions. Though it looks like a challenge, fortunately we have a very nice AI methodologies to deal with that. Optimization is another important field where we try to deal with finding the best. For example, if you have a coffee cup like this, if you have a coffee cup, and if someone asks you what is the best shape of a cup, probably, I guess all of us might think twice. Actually, what is the best shape? Because we are seeing this since we are a small child. But there is another shape. What is optimal shape? Probably we need a handle, we need the shape, we need this weight, we need the material should be like this, the cost should be like this, the life, the looks. Even for many real world problems, we don't know the exact solution. So how about we use AI for helping or finding those possible best solutions? So that is actually the role of optimization, where we try to find the best solutions given the concept, given the current situations related to a problem, environment, system, etc., etc. Okay, could be related to any problem. So basically, we can categorize them into few functional blocks. Approximate reasoning. We have various probabilistic models, fuzzy logic or offsets. Functional approximation, we have neural networks, decision trees, supported to machines, various other machine learning methods. Randomized search optimization, we deal with meta heuristics or even classical search methods like simulated annealing, taboo search, evolutionary algorithms, swarm intelligence, the entire string of optimization methods. So you can imagine you have these nice clusters. So evolutionary algorithm, I guess all of you are very familiar with evolutionary algorithms based on Darwin's theory of natural selection, where the idea is fitter the parents are, they will find the opportunity to get food and produce better offsprings. So, and basically we start with a population of solutions, we select the best out of them, we try to alter them, we get the next generation, and we keep on doing this until we get the required solution. It's a very simple flowchart, an evolutionary algorithm. Neural networks based on mammalian learning. We humans, we can learn from examples. For example, if you show a small child that there's a cup, a 1 year or a 1.5 year old child, a small child, you show the child and tell him or her that there's a cup, and next day you show the child probably a different cup, and the third day you show the child another cup, and probably after 2 weeks you show the child something very different, which is not shown before. The child can still understand that it's a cup. The child not only learn the shape, how it looks, etc., but also can generalize. So that's the basic idea of artificial neural network, where we try to mimic our brain. We try to connect neurons in layers. We try to use for various function approximation tasks. There are several learning methods, probably about 100 different learning methods. This could be easily like a one, almost like a 2 weeks lecture in a university course. I don't have time to go into details. So basically, if you have different number of hidden neurons, for example, if you have 3 neurons, 6 neurons, 20 neurons, you could see that the decision boundary it's very interesting. So when you have more hidden neurons, you could see that how well you can make the decisions. It is more in detail, and probably we can easily categorize or classify the patterns much well or more efficiently. A recent trend is the field of deep learning, where we try to use such neural networks to understand high-level features. For example, I try to understand people based on certain high-level features. For example, I know someone next. I don't know how to see his face, but just by seeing the way he walks, I can understand that it is Mr. X. Similarly, Mr. Y, I don't know how to see his full face, but even if I hear his voice, I can understand that it is Mr. Y. So basically, we humans, we try to have this nice capability of learning high-level features. So we are trying to learn or make use of this in a neural network, and we call it as deep learning, where we have different neurons meant for different purposes. For example, some neurons would learn the horizontal lines, some would learn the circles, some would learn where the circles are placed. For example, here we are referring to handwritten digits 0 to 9. So you can imagine it as zeros. Then you can imagine some circles for 2, 8, 6, 9. So basically, there are neurons which are specialized to understand how these circles are placed. So basically, training goes more like a autoencoder, where each layer is trained by the previous layer. Another important field is a field of evolutionary artificial neural network, where we try to use evolutionary algorithms to design neural networks. So basically, we try to encode in the form of a chromosome like this, and then we try to use crossover and mutation. If you know the genetic operators, you know that these are very simple to operate, and you can actually change the network very easily. Or another way, we can actually find the best performing network, or it's more like an optimization problem. So in this case, we try to use evolutionary methods to find the best networks. One of the methods which we used is what we call as flexible neural trees. So for many neural networks, we need to actually prepare certain things in advance. For example, how many neurons we need, what sort of connectivity, what sort of activation function, how will I train the network, how will I stop the network, what are the parameters. So this is actually a big problem in designing neural networks. So we designed a network design probably like 15 years ago. We started with flexible neural trees. We just need to present only what is called as instruction set. So we have +2, +3, +4, +5, +6. So +6 means it can take 6 instructions. So +2 means it can take 2 instructions. And you have the terminal set, which is x1, x2, x3. So basically, from these 3 variables, you can actually build what is called as neural trees. So you can imagine a forest of trees just by changing some operators here and there. You can imagine you are looking at so many different types of network for solving a single problem. So that's the basic idea of flexible trees. I will skip the details. You can find some papers. So one example I just want to illustrate is to show how well it performs with time lags and without time lags. For example, this is a famous time series data, gas furnace time series data. So you would see that the case 1 and case 2, the last two rows, case 1 is without time lags and case 2 is with time lags. And you would see on the last column, the bottom two rows, you would see that with time lags, the error has gone down by almost half. So time lags helps to improve the performance. This is another famous time series, Mackey-Glass time series. Again, case 1 is without time lags and time lags. Time lags helps to improve the performance. This is another problem related to network security, intrusion detection. Again, if you use this, so we used the MIT Lincoln time dataset a long time before, and there are 5 different classes. So for each category, from 41 variables, we are able to reduce to 9 to 10 variables. You would see that for each class, you would see that these are the important variables, and these are the sort of the error rates for classifying different attacks. Colon cancer dataset, again, you could see that, it compares very well with other classifiers. Then leukemia dataset, these are all benchmark datasets, which academics and others have used. So, but we come across a problem when we try to design such networks. We have small network, which is not very accurate, or we have big network, which is very, very accurate. So the user or the designer finally ends up with a confused state, whether you should use a small network or whether you should use a big network. So we have a problem with deciding. So we try to formulate it using multi-objective optimization. So where we try to have a trade-off between various objectives. So we also try to have a complexity, accuracy, and also the activation functions. So once you have a trade-off between these, then we can have the best networks. Again, we have some benchmarks, evaluations, and we can have a very small network like this instead of having very complex network. So in the previous one, we saw classification benchmarks. This is regression benchmarks, some regression problems, well-known regression problems. Coming to the last part, I think I will not take more than 5 minutes. So fuzzy expert systems is another important area, or a field where we try to use approximate reasoning. So I talked about functional approximation and some of the models, and I presented which model we developed. Now we talk about expert systems or approximate reasoning and how we try to evolve this particular area. So fuzzy logic deals with imprecision and uncertainty. For example, if you want to describe someone who is old, if you use Boolean logic, you will say someone who is 80 years old, someone who is 79.99 is young, which is not correct. But if you use fuzzy set, we can say that someone who is 75, he has a degree of association of 0.9, or he is 90% old. So that is the beauty of fuzzy logic and fuzzy ifs and rules. If you have knowledge, you can translate that in the form of rules, which is easy to encode, and you can easily make nice models for solving various problems. So Mamdani inference system, Takagi-Sugeno system, if then rules, if pressure is high, then volume is small, where inputs and outputs are there are a lot of challenges. Variables, relevant system, function we would use, how many membership function we would use. Okay. So one way to overcome is using the concept of Neuro-Fuzzy models, where we try to use neural network type learning models. So if you use Neuro-Fuzzy models, you could see that you could see that, this is for the Mackey glass time series. You could see that the error has gone down. For example, the one you see on top is a traditional neural network, and when you see with Neuro-Fuzzy model, you could see that the error is almost reduced to 1/3. Okay, Neuro-Fuzzy models. Similarly, we can also use Neuro-Fuzzy models. So evolutionary fuzzy models. So if you use evolutionary fuzzy models, you can see that error is much lower. For example, if you use Neuro-Fuzzy 0.00, and if you use evolutionary fuzzy, you can see that error is still reduced by half. So optimization plays a big role in designing fuzzy expert system. And one of the ways which we did was what we call as flexible trees. Using a very similar concept, we try to use tree concepts to design fuzzy expert systems. So basically, by only providing instruction set and operators, basically you have trees like this, which translates to fuzzy systems, and you can easily use it for solving problems. For example, this iris data, you have like 4 features, sometimes you need only 3 features. Okay, and you get accuracies like this. And this is the wine data, another benchmark. From 13 features, you're able to reduce to 4 features with good accuracy, sometimes 5, 99.4, 6 with 100. So you could see that, but again, we end up with a problem with a small model with low accuracy, or a complex model with high accuracy. So we need to have a trade-off between complexity and accuracy. So again, we try to use a multi-objective fuzzy expert system. And here we try to use type 1 and type 2 fuzzy systems, because type 2 fuzzy systems are able to model uncertainty in a very, very nice way. So again, you would see that from type 1 to type 2, from type 1 single to multi, type 2 single to multi, you could see that how the error changes. For example, type 1 single is 0.0043, and type 1 multi, you see that error is reduced. And when you go to type 2 multi, you would see that error is reduced to a very low level. So some of these, and this is a very nice occasion where we have 300 features. So when you have 300 features, it is practically impossible to have a fuzzy expert system. So basically, we try to use this model, and then you can see that once you have a type 1 multi, you would see that error is like this, and type 2 multi, error is like this. And for type 2 multi, you would see that we only have 4 features, and type 1 multi, we need some features. So you could see that there is a big difference between type 1 multi and type 2 multi, and type 2 multi seems to work better. So coming to conclusion, so I guess we see a big convergence between cyberspace and physical space under the umbrella of Industry 4.0, and AI will enable big data, robots, cooperative more effectively and seamlessly work to solve big problems and bring back a lot of value to the community. And I guess we have challenges from AI data sciences. We need fast learning methods. We need to achieve global error rate. And many times it is also important to find the best data. Because if we find the wrong data, then many times we get bad results, and we complain that AI doesn't work, data science doesn't work. So the more time we spend to understand the data and acquire the data, to make sure that data is of good quality, authentic, then we might be also able to build better models. So thank you so much for listening, and I'm open to questions.
Okay, thank you. Thank you very much, sir, for your nice session. Now, as we have promised at the beginning of the session, I will move to the question answer session. We are left with 5 minutes. So we got few questions. So I would like to request request Abraham sir to put some lights on the question. I'll be reading the question, and if you can put some lights on those questions. Let me take the first question, which has been given by Dr. Pooja Jha ma'am. She has written, sir, can the end user manage the velocity, variety, volume, and varsity of its current information flow? Is it possible to control by the end user?
Well, actually, these are mostly coming from the application side. So basically, it is more like you are seeing water from a tap coming. So basically, if you want to control, means basically you need to just close the valve of the, or control the valve of the tap. Or there are several ways for handling such data. For example, you can use fragments. For example, you can just take a sample of the inflow of data and then you process it, and then you try to decide whether you want to analyze more or things like that. So there are several ways to handle V's of data, several ways. Depends upon the application and depending upon the processing needs, the time availability, etc.
Okay, sir. Thank you. Thank you very much, sir. Now we'll move to the next question, which has been asked by Ms. Soni Gupta. And the question is like that, what is the future scope of manpower? If everything will be done by machine, I think by Industry 4.0, many people of low level who are not very educated, they may lose their job. Please explain the impact of Industry 4.0 on human.
That's a very, very interesting question, and especially I think for a developing country like India, it might pose a lot of challenges. But at the same time, I would see that from a positive point, it would also uplift the society. You could, for example, now if you want to do business, for example, if someone near Delhi or some major cities, you can do business only if you go to those cities. But I would say that those things might change because of Industry 4. For example, someone in a remote village also could work, as in the same way like he or she is working in a metro. So certain things would change drastically, and I guess there's a certain need for people to upgrade their skills. That is mandatory. For example, the workforce, or even I think for universities, educators, there's a big challenge that we should train the next generation of students with the latest technologies that could be useful for Industry 4 and for the industry needs. So there's a big challenge in from that dimension. But overall, I think that it will be beneficial to the community at large, and especially for developing countries like India, where I would see more small villages turning to small cities, the metros getting bigger, and probably it will swallow neighboring small cities. So those type of things will happen in a very big scale. But I think we have to be possible and right.
Okay, sir. Okay, thank you. Thank you very much, sir. And now we'll move to the next question. Just a second. Next question. Okay, let us look at the question. The next question has been asked by Argha Kumar Guha, who has asked why overfitting model is not good for training. Why overfitting model is not good for training?
Well, overfitting means it is more like you're trying to memorize the data, but you cannot really generalize. So basically, what we want our model to do is we want to learn, want to make the machine learn things which are not taught before. Overfitting means basically the machine would fail to recognize such unknown patterns. So basically, it can only give you inputs which are directly trained, not something which is not trained. So basically, in machine learning, what we want is generalization, not only learning, but generalization. If you remember the way I told about teaching a child with a cup, we want a child to recognize a cup which was not shown before. That is the success of AI. So basically, we cannot afford to have overtrained model or overfit model.
Okay, thank you, sir. We'll move to the next question, which has been asked by Arijit Ghoshal. The question is, how to determine the number of neurons in the hidden layer of neural network?
That is a NP hard problem. So basically, if I can tell that, probably I might end up getting a Nobel Prize. So So basically, it's
Okay.
NP public. So basically, for a given architecture, number of neurons, the connectivity, it is going to be NP hard problem. So basically, we use some learning methods, we use some heuristics to find some combinations, and try to find somehow to solve the problem. So basically, there is no straightforward solutions to your question, how many neurons I should use. But there are some heuristics what to start with. For example, if you have this many rows of data, this many number of features, probably you need to start with this many number of neurons. But again, that will not work in reality, because it's NP hard, NP complete part. So there is no straightforward answer for that.
Yeah, so that is why it is a penalty. A penalty is involved. If you make a mistake, again you have to come back to the beginning. So trial and error method. So I think you are absolutely right, sir. Next, we'll move to the next question, which has been asked by Tanisha Kundu madam. The question is, as a beginner with a mediocre knowledge of the methods, how do we start off for solving a given problem? The question is, with a limited knowledge on this particular domain and on a particular methods. So how do we start off for solving a given problem?
Well, I think the first way to look at would be, first you need to understand the problem itself. What is this problem about? Whether it is related to some functional approximation, or you need some approximate reasoning, whether you need some optimization, whether you need a combination of everything. Then you need to find out the best methods for this. Always start with the baseline method, and then you slowly build like more methodologies to do. For example, you have a regression problem. For example, you need to predict the number of COVID patients tomorrow. So given number of COVID patients today, you want to predict what is happening. So for this, you can use a neural network, you can use a product machine, you can use entries, but then suddenly you realize that certain information is not very precise. So there is some imprecision. And then you need to build some approximate reasoning. So you need to build a model which can also understand some imprecise data. And then you build that model. And then you find that results are not still much improved. You need to fine tune it. Then use some optimization methods to still fine tune your model. So basically you can see different ways of building the model at different stages. So always start from scratch, and then depending upon the need, performance, you try to add on more methodologies, fine tune it, optimize it until we get the required. So basically, it is more like, I would say it is more like you do things in a kitchen. So if I go to kitchen, like I cannot make straight away some dal curry, or I need some practice. And you need some expertise which you build over practice. And AI is exactly like that. So we need to start from scratch, slowly get the expertise, and then at one point you see that, oh, if I do like this is the best way. So it is a matter of practice and getting expertise. And practically, I would say that it is not at all a complicated field. It is very easy, and it is very, very fascinating, and very, very enjoyable. And nowadays you can see it being used everywhere. So there is a lot
Thank you,
of
sir.
scope for future and for developing many things.
Thank you, sir. As we are running out of time, there are lots of questions, but I'll try to take the last question as and a generic question, because it may it may cover the lots of the other questions also. This is the last question which has been asked by Kishore Mandal. The question is it possible that every industry use AI for their own flow of work in future?
Yeah, I guess that is how the world is moving to. Basically, those who will not use modern technologies, they might not be able to offer the products at a competitive price, or they will lose competition. And I guess this is something which is happening in India, for example. And when I compare with China, I guess even India imports a lot of things from China, even though our manpower cost is a lot lower, because China is into full automation. So basically, they can supply things at a much lower cost than what we produce in India. And this is a problem with automation. So unless you automate, unless we use modern machineries, modern technologies, we cannot be competitive. Even we cannot make our people happy. So how can we make others happy? So I think it's a must to survive. So basically, in the future, I guess every industry should make use of modern technologies to compete. Because unless we compete, we cannot offer reliable, efficient, economical products and be competitive. So, and I guess that is actually one of the future directions which any industry should go forward with.
Thank you very much, sir. And our sincere apology to those attendees whose question we could not attend because of shortage of time. We have already crossed our time. So here we are at the end of the session. So before we conclude, I would like to invite our Honorable VC sir to say a few words of blessings. Over to Honorable VC sir.
Thank you for such an exciting talk, and I could not get up even for a single minute. But I have a question. I was reading one of the articles related to the present COVID data management. So there was an equation which says x of t, which means say death. Death at a particular time t is equal to some constant which is also at a time dependent ht multiplied x at t minus 1. Which means xt by xt minus 1 is equal to ht, some function of time. So and then they were trying to predict that after so many months or of so much of time the COVID will be off. Are AI models also being utilized to understand this pandemic and its end somewhere, or this particular equation really was not really understood, because if the slope itself is dependent on time, so then nothing can be said much. Anyway.
Well, actually, the COVID-19 data or the COVID-19 pandemic, the way it is moving, is very difficult for us to predict. Even for AI, it's very difficult to predict. Certain movement of data, it is not a natural flow of data. For example, if is in the lockdown, if there is a curfew, or if policy makers need new direction, can affect the flow of a number of patients and which AI cannot foresee. So COVID-19 itself is a very complicated data, complicated problem to make long term. That is why many people, they are still relying on the base model. So, pandemic prediction community, there are some very nice models. You have a population infected and then cancel more infection and how it will pass the entire population. There are some baseline models. I think that is probably the best model to model COVID. You can try to fine-tune performance depending upon how the lockdown period, how the policy. AI models, I guess it is very difficult for us to predict, for example, what will happen during September. I think it is very difficult for us because the numbers are growing. 45,000. 2 weeks ago it was half. It is going, in a very alarming rate. So I think, I think it's still better to go back to the baseline models than relying on AI, because like I mentioned, it is not an easy data set to handle because of a lot of uncertainties.
Okay. Sir, would you please unmute your mic?
Yeah, I once again officially and personally thank you for exciting us. I think those who are wanting to get into AI field, since that also is my interest a bit, because I'm trying to read certain patterns in the in some aspect of students' life, and if artificial intelligence can be used. So the sequence has been very clearly laid out, and people can follow and use the baseline model to the more complex models with time. Once again, I thank everyone who has attended it, and taken the advantage. There are very large number of books also available on artificial intelligence, and of course some basic ones are still running. So academic field is wide open for this particular topic. Thank you. Thank you very much, sir, once again.
Thank you
Over
very
to
much.
you. Thank you.
Thank you. Thank you, sir, for your kind words of blessings. Now, let me take the privilege to give the formal vote of thanks. First of all, I'd like to thank our Honorable Founder President, sir, our Honorable Chancellor, sir, our Honorable Senior VP, sir, and VP, sir, for providing this opportunity to conduct that kind of webinar during this pandemic situation. Now, we are always thankful to our Honorable Vice Chancellor, sir, Professor Dr. Raman Kumar Jha, sir, who always not only encourage us to conduct that kind of session, even sir personally attend those sessions to motivate also us also and our students also. So thank you very much, sir, for your kind presence. We are also thankful for our respected director, sir, for his presence, for his encouragement, and for his motivation. And we are also thankful to our respected registrar, sir, unfortunately, who is busy with some other admin task today. And I must thank to our IT host from Noida side, who is taking enough pain to organize, to conduct that kind of, to provide that kind of IT infrastructure, to conduct that kind of webinar. Even to share with, we are conducting that kind of webinar since March 2020, just after starting the lockdown session. We have already crossed conducting more than 60 webinars under the AUJ banner only. So thank you very much to all our IT staff and IT admin from our AUJ campus also for their sincere support. And I'm also thankful to all the my esteemed colleague faculty members for attending that session and for encouraging the student to participate that particular session to make it successful. As you can see, near about more than 130 students participants has attended that particular session. So it's a very good thing. And personally, I would like to thank our Professor Dr. Mithun Chakraborty, sir, for arranging that kind of speaker for our students. Thank you very much, sir. And last but not the least, again, I'd like to thank from the core of my heart to our respected speaker, Dr. Ajit Abraham, sir. Sir, will be looking forward to conduct that kind of session in future also, and if possible, we'll also try to hear you face to face in our campus also whenever the lockdown will be over. So with this, I'd like to thank each and everyone whose name I have not taken